this video we're going to continue with section 3.4, but this time we're going to go over the quotient rule. And the quotient rule is about what the derivative is of f divided by g, one function divided by another. What's the derivative of that? And if the product rule was any indication, we know what it's not going to be, right? F divided by g prime is definitely not going to be f prime divided by g prime. It wasn't like that for the product rule, so it's probably not going to be that way for the quotient rule, and indeed it's not. Okay? So whenever you see f divided by g prime, don't just do derivative of the top divided by the derivative of the bottom. It's just not what it's going to be. Instead, we're going to get this. Well, instead we're going to get this. We're going to get f prime times g minus f times g prime divided by that whole thing, g squared. That's what the quotient rule is. And what you'll notice, if you're already familiar with the product rule, is that the top looks exactly like the product rule, except that there's a minus instead of a plus. Okay, so let me just highlight that. So be careful with that minus sign. And then, of course, you just have to take it and then divide by g squared. Alright, so that's really the only difference between the product rule and the quotient rule. That's one way of remembering it. Another way could be the following. F is the top function, so let's just write top. G is the bottom function, right? So the quotient rule says, well, you take derivative of the top times the bottom minus top times derivative of the bottom all over the bottom squared. Alright? And if you keep saying that to yourself, well, hopefully it'll stick, but this is another way of remembering it. Okay? So let's do some examples. Let's take function h of x. For example, 1 plus x divided by 2 minus x squared, say. Well, let's make it plus. Okay, so the derivative of that is going to be what? Well, it's obviously a quotient, right? Because it's 1 plus x, one function, divided by 2 plus x squared, another function. And so here's the top function, obviously, because it's on the numerator. And then here's the bottom one. So how does this thing go again? It goes derivative of the top, that's just going to be 0 plus 1, because derivative constants are always 0. Derivative of the top times the bottom, minus the top times the derivative of the bottom, 0 plus 2x. And this goes all over 2 plus x squared. But that thing squared. Alright, so let's just do a little bit of cleanup here. 0 plus 1 is 1. 1 times 2 plus x squared, well, that's just going to be 2 plus x squared. Next part, we have 1 plus x times 2x. So that's going to give us 2x and 2x squared. But the minus sign distributes, so we'll get minus, minus. And then over 2 plus x squared squared. And if we just clean the top up, you see we're going to get x squared minus 2x squared, that's negative x squared, minus 2x plus 2. And again, over, well, let's write it like this, x squared plus 2 squared. And so that's the final answer. Okay? So all we did here is apply the quotient rule. That's the first first part, okay, right here, that's the quotient rule. And these last two steps are just us cleaning up that expression, all right, and giving it in a nice form at the end of the day. Okay, so that wasn't so bad. Let's do another one. Let's do one with slightly more complicated functions. So let's make h of x, and this is example 2 now. So let's let h of x be 1 plus x divided by ln x. Alright, so obviously top function is 1 plus x, bottom is ln x. If you take derivative of that, well, in fact, let's put x ln x on the bottom, just so we could combine a product rule and a quotient rule together, and you'll see how this is going to work out. H prime of x is equal to bottom, right? Or let's do it this way. Quotient rule says derivative of the top, that's going to be 0 plus 1, times the bottom, nothing happens there, minus the top, 1 plus x, times the derivative of the bottom. Look, I'll put a big box here. The derivative of the bottom is going to require us to take the derivative of x times ln x. Well, that means we're going to have to use product rule. So product rule on the bottom, so derivative of the first is 1 times the second, ln x, plus the first times the derivative of the second. That's 1 over x. And now we do all over the bottom squared. X squared times ln x, that whole thing, squared. Not ln of x squared, it's ln x, that whole thing squared. Okay? Now if we just try to clean this expression up, we have x ln x on the top, minus, well, let's look here in these square brackets. What is that? That's just going to be ln x plus, well, x times 1 over x is the same thing as x divided by x. That's just 1. So 1 plus x times 1 plus ln x, that's going to give us 1 plus x ln x. I'm just foiling it out, plus ln x plus x. Okay? And I still have on the bottom x squared ln x, that whole thing squared. And you'll notice here that when we distribute this minus sign, x ln x, those will go away, right? So what we're left with is going to be negative 1 minus ln x minus x, all over x squared ln x squared. Ln x squared. Okay, so that's the final answer. Great. And what I want you to notice here is that we did apply the quotient rule. That's what we're applying to h, but while we were applying the quotient rule, we know we're going to have to take the derivative of the bottom or the top eventually. And when we get to taking the derivative of the bottom, we notice that we're going to have to use a product rule there. So these questions can get more complicated in that way. You might have to use multiple rules within the rules to get the derivative that you want. Now that might sound like a lot, but with practice it should get a lot better.